Hello everyone, Colin Canet here for Woodwork Web. And today we're visiting the Edge Sharpening. And here we are with Tom Saxby. He's the owner of the Edge Sharpening, and we've got a really unique thing that we're doing right now. Tom is actually going to be showing us how he makes blades for profile grinders, a profile for a machine. There's no profile for this to buy. Tom is actually going to make it because you can't buy the wood anymore. So he's going to show us the process of how this works.
So in the process of making a molding of a particular type or a molding for an antique home where it has to be reproduced, what would be done is either I would get a wood sample with the contour on it, or I will get a sheet with the profile that they wish me to make.
Okay, like you can see the profile in this here. So this is a special profile that you need to cut, is that right?
Exactly. This one in particular is for a wainscoting type molding, which they're going to use for a secondary purpose. That's the reason it's so long.
Oh, I see.
Okay, so they're kind of using two out of one knife. So in this case here, the customer gives me the diagram, and then I in turn take it to my production upstairs, make a CNC plastic reproduction of it. Then in that process after that, we would make some blank stock knives.
Oh, I see. So this is a different profile for something else.
Because the other one loaded.
You can see the little nubs on there.
This comes from this.
Oh, I see. Okay.
Okay, so this is another profile for another set of knives.
This is like your template then.
Exactly.
Oh, okay.
So then our hard stock knives, various shapes and sizes can be obtained depending on the molding structure we wish to build or the knives to make the molding.
I see.
Then this is produced into the profile of a plug, a plastic plug.
Okay. Okay, so here we are at the profile grinder, and this is where that template is set up. And I think Tom's just about ready to start this machine up so we can actually watch it grind. Okay. Okay, so you've got the raw blades on here. This looks like this is the grinding blade here that's actually going to be doing the grinding.
Yes, this is a ceramic stone.
Okay.
Used for, if you look at it, here's our blank knife, loaded into the head. This head is what is in the actual profile grinding machine, the machine that makes the wood.
Okay.
So the knife is loaded into a head in this aspect. So all we're doing is making the knife for the head. So then what we'll do is follow our profile that we made out of the white plastic, and then we'll proceed to make the knife. Set it off, touch it, and then we will just follow our profile along until we have to cut some more.
Okay, Tom, I see this grinding actually takes a little bit of a while to go through all of these, but this is looks like you're showing me a profile here of one that you've previously cut. Is that
correct? These knives then make a tongue and groove, put in a shaper machine and make tongue and groove. And there you go. Your knives then get made to make your profiled corner.
okay? So this is actually these profiles, and that's how they fit together. So this is a cabinet shop that you say is
right, and that'd be a cupboard door.
That requested that. Look at that.
Raised panel cupboard door frame,
Yep.
I guess you'd call it.
Yeah, that's amazing. That's amazing. That's
So-
quite the machine.
So that's the process for profile grinding. So
These would go on what kind of a machine then?
that can go in one of these, but also can go in a shaper.
Okay.
With anything with a corrugated knife head.
I see.
So this is a regular corrugated knife head.
Okay.
So there's several machines that will take these knives,
Oh, I see. Okay.
and that's how they work. So then you got the profile given to me on paper.
Yeah.
I then produce a plug
Yeah.
or a plastic reproduction.
Right.
Then put the knives into the head, and in particular steps through the stages, come up with the knives to then actually make the profile
Yeah.
on the wood
Yeah.
of various shapes
Yeah.
or reproductions
Okay.
of old or whatever's necessary.
Well, I guess when they wear these blades out too, they can come back to you because you've already got the template.
Correct.
So it's just a matter of whipping up a couple more blades for them, and they're good to go again.
We at the edge give you the plastic to go with the knives
Okay.
because it needs to be resharpened according to the plastic.
Oh, I see.
So when resharpening is done, several occasions, the plastic will come with it.
I see.
Then the knives will be resharpened
Oh, I
and
see.
reprofiled
Okay.
exactly the same as they were.
Wow, that's amazing. Thanks, Tom.
Okay.
Okay, we're with Tom Saxby again. And Tom, when you get a blade that comes in for sharpening, this one that you're holding here, that's a pretty nasty looking blade. I can see the shoulders are, what do you do with it when a blade comes in?
Okay, well, we received the blade in this condition. First, give it a visual inspection to see if it is, let's say, worth repairing and resharpening. If it's all bashed up, then at that point we have to make a decision, should we go further? If we're going to go further, we would then take the blade and we would then give it a brief inspection, then we would put it on our hook and we would place it in our sodium hydroxide bath. That is the same as any saw shop's purchasable saw cleaners, same product, just a large bath, so we can do more blades.
Okay.
Then after it comes out of that, it will be rubbed and scrubbed, and
Right.
all of the wood particles and gum will be removed. Then we have a blade very similar to this.
Pretty shiny looking now.
Okay, it's all clean, ready to go for further inspection. Now this is a 1024 flat top. What we would do then is we would go over to our run-out gauge, which we'll show you.
Okay.
And we'll check it for run-out or wobble, in some cases people call it.
Okay, good. Let's have a look at that.
Pairs and decide what we need to do, take out bumps, fatigue in the blade, in the plate, various things can be done in the repair process.
Okay.
It's a bit of a process to go through when telling somebody, but on this particular machine, all we're doing is we're going to slowly spin the blade and we're going to check our dial indicator that will give us a various of run out, where our high spots might be, where our low spots might be in the plate.
Okay.
So it somewhat gives us a situation of where to go to repair that blade.
Okay. So now we're in front of the CNC machine, and of course the CNC machine is far more accurate for modern day blades in terms of sharpening. But what do you have to do in order to set this up, Tom? How do you set this up?
So as we've gone through the blade that we've been using, this one here, the 1024 flat top rip. So then what we do in this case is we go to our programming and we select our blade. In this case, it's a flat top, single tooth flat top, no combination pattern. So then we pull up the blade. And then the package for this blade, so we scroll up to our blade. Most predetermined packages, but we can make anything. So now we've pulled up our blade, and in this case of the programming part of it, we're going to tell the machine the variations of the blade. It's a 250 millimeter or 10-inch diameter, 24 tooth, and how much do we want to take off? In this instance, we're going to take off a .120, which is about 3.5 thou, and a little bit more off the top, because inspecting this blade through the process, there's a little bit of chipping on the top. So we want to clean that up for the customer. So then now we're going to take this package that we've made up, and we are going to then load it in, save and automate, loading it into the file that operates the machine. So now we just wait 1 second, conversion, and then now the machine is ready to accept the blade, which we told it we're going to grind.
Oh, I see. Okay.
So now we're going to center it on the centering pin. And then we're going to move it up into position. Now this probe mechanism here in the very forefront of the machine is pretty much the brains of the machine.
Okay, where is it, Tom? Where's the probe?
The probe being right here,
okay,
on the head of the unit here.
Yeah.
So
oh, I
there
see.
You go.
Yeah.
Okay, so now this is our 0 point. That's where it tells me to put the blade in place. So this is the blade we want to grind. Now we need to tell the machine it is in place. So what we do is we just look for the small light that says it's in place, and then lock down our plane, and then close the door, and then we're going to automate the program. So now it moves the next tooth into position.
Okay.
And starts to measure.
Oh, I see.
Measures the side curve. Then now it takes 3 individual hits on the face to triangulate the angle. What is that tooth on? What angle?
Okay.
Comes back to measure. The measurement it's making now is to see if it took off the required amount that I gave it in the package.
Wow, it checks itself.
To continue, okay?
Yep.
So it was a little light on its cut, made the second cut, now it will continue to each tooth and be exactly the same.
Okay.
If you look at the head, it doesn't move, only back and forth. So exactly the same angle, each face
oh, I see.
will be produced at the same angle now.
Okay. Wow, and that's spraying oil in there to keep that cool.
Oil coolant with a 300 grit diamond wheel.
Wow. So here we are at the hydraulic machine, and it's used for alternative grinding for blades that you don't need that critical a grind on. Okay, Tom, so tell us a little bit about the hydraulic machine here.
Okay, in this situation of the hydraulic machine, generally used in the large saw section, mill saws, maybe truss saws, things where sharpness is more of the outcome rather than 100% accuracy. Because when we're trimming large trusses or beams and things to length, it's just that. It's to length. It's not a custom fit. It's not anything like that.
Okay.
We're not trying to save materials and that sort of thing. So in this situation of the hydraulic machine, back in its day, very good machine, helped us off either a lot. It is very time consuming to actually set a blade up. In this case, it's a facing wheel, and The topping wheel is up here. So you have to change the whole head action. Whereas we saw on the CNC machine, automatically it does it. The references for this machine are dial indicated, so they're not strategically placed. They're not digitally informed to a computer. So the advantages to this machine really is it does very large blades. As far as accuracy, it will make your blade sharp. It will do a fairly nice job. It's one other thing, a little bit on the downside, is it's water coolant, which gives you a little bit grainier finish in your carbide. So with today's carbides, micrograin carbides, it gives you a slightly grainier finish on the carbide. So what that results is less time cutting your wood. So more sharpening will be necessary with a water-cooled sharpening. So that is some instances. And the hydraulics being about 15% fluctuation at any given time. So as far as this machine goes, it's slow. It will do the job properly manned, but there is a lot more in fluctuations and variations of things that you get at the end. Whereas the CNC machine is 100% accurate. We can watch this little curve go. It's pretty simple. So that if you watch the whole action, it's not as fluid. Water coolant, so water has air in it. There are variations of things. Whereas oil, there's no air. Consistent speed, consistent cooling, the smoothness is there. So you can see how the operation goes. It is slow.
So blade sharpening is far more complex than just throwing a blade in the CNC machine and turning it on. But there's even more to sharpening a blade to make it last longer. What do you do to make a resharpened blade last even longer, Tom? What are some of the things that you can do?
Well, in the one aspect of the things that we're thinking about is as our blade gets sharpened a bunch of times, the shoulder height becomes the same height as the tips.
Oh yeah, I see that.
So the problem with that is the heat made up when the blade is doing the cutting, the heat runs strictly through the plate, which in the cases your plate gets hot, it starts to gum up and collect things more and it sticks and it just becomes an unruly mess. In the case of the edge sharpening, we'll do a process called backing off. Now if we look at this blade, the height difference of our actual cutting tip is lower than our shoulder just by a few thou, but it's enough. When the dynamics of the blade and the blade speed is turning at speed, then the small particles and stuff that would normally gum up is then ejected off of the tip because it's not sucked back into the hot plate. So that is a thing. Also at that stage, makes your carbide tip sharpness last longer because it isn't heating up so much. So there is one more thing that would cause your blade to last longer between your sharpenings. So more feet, run feet per foot, more through that blade before it gets sharpened.
Wow. That's great.
So that is another process we do here at the edge, maintaining your blades to make them stay the same as the factory blade.
Wow. Let's get a close-up of that so people can see exactly what that looks like. Okay, so we're here with Eli, and this is the machine that cuts rotor bits?
Yeah.
Okay. And how does it, what, the rotor bits come on, they sit on here? How does it actually work?
The rotor bit just sits in this little chuck here. Basically all we do is set the bit up so it's square to the wheel.
Okay.
So each bit will have a different angle that it's going to run at, and we can change this to accommodate whatever angle our cutter's at.
Okay.
And then it just runs back and forth in front of the wheel.
Oh, I see, okay. So how long does it take to sharpen a fairly simple bit here? How long does it take to do on this
about
machine?
5 minutes.
Okay.
All in all. your setup and everything.
So this is grinding the carbide, this is sharpening the carbide, so I'm assuming this is a diamond wheel, is that correct?
Yeah, exactly, diamond grit, yeah.
All right. How many times do you have to replace the wheel on there? How often does that last?
You should get about 6 months out of them.
Oh, okay.
You get quite a while, really.
Now we're in front of a tool and cutter grinder, and this actually does spiral type bits, so carbide bits, drill bits, that sort of thing. And in a second here we're going to show you a close-up of where the bits fit into the chuck and how the machine actually operates. Okay, so this is the grinder now. This is the spiral grinder. So, Eli, this is where the bits go in here, is that correct?
Yeah, if you had a rotor bit or a milling bit.
And it'll do what? What kind of bits will it do? Steel?
Yeah, steel, carbide.
Okay.
Pretty much anything.
Okay. So it'll do like the solid carbide bits that you can buy?
Sure.
Okay.
All your annular cutters and milling bits will all be done on here.
And this little wheel here off to the side, I see this looks like it's the grinding wheel, is that correct?
Yeah, that one's the diamond grit if we're working with a carbide piece.
So is this like an automated machine then? Because spiral bits are pretty complex. How does it actually, does it spin the blade at the same time, or how does that work?
If we're doing a spiral bit, it would be in an air bearing chuck.
Okay.
So it'll be in there and the bit will sit on top of a pin, and it just follows the pin, and the air bearing allows the spiral to move, and the wheel sits stationary.
Oh, I see.
So we bring the wheel into the bit, and it follows the pin,
oh,
and then your
I
air
see.
bearing will pull it or push it past the wheel.
Pretty fascinating.
Yeah.
So does this machine get used a lot? I guess if you're doing drill bits and...
Yeah, pretty much every day.
So auger bits and things like that, you can do the big auger bits?
Yeah, a lot of the augers we do by hand.
Okay.
It's just quicker and easier. There's no reason to do them on here.
Okay, I guess if they're steel, it's... yeah, you can do that.
The ones with only one cutting edge, it's not like they need to be the same on either side or anything.
That's true.
So.
Yeah. Good.
Yeah.
So this is the flatbed grinder, and we're back with Eli again. So this is the flatbed grinder, and we're back with Eli again. Eli, this looks pretty complex up here. What are these buttons? I guess there's an up and down you control. What kind of things are you controlling?
These buttons here control our height. They bring the wheel up and down, and then we can turn on the motor and turn on the feed. Okay. Control it moving back and forth.
Oh yeah.
We need water. Keeps it cool.
Oh, okay.
And then we can set how many times we want the wheel to feed down, and by how much. Okay. And then how many times we want the wheel to spark out when it's all done, just to polish the edge.
Oh, I see, okay.
And then these ones control our magnet, turning it on, turning it off, and demagnetizing it.
Oh, I see. So the blades actually go on here, they're magnetized to hold them, is that what you're saying?
Yeah, basically the whole bed's one big electromagnet.
Oh, I see.
So we'll set the blades up on there, magnetize it so they sit nice and flat, and then the bed changes its angle.
Oh, I see.
So whatever angle your knives are at, we bring the bed up to that, lock it down, and then we just run the machine back and forth over top.
Okay. So this is the bed, and this is all magnetized, so you can magnetize and demagnetize the blades when you put them on. Is that what you were saying?
Yeah.
Okay. So what we're seeing at work here is a sharpener for blades like planer blades, jointer blades. This even does Zamboni blades. You can see that it's got like a 12-foot bed in it. And although the sharpening edge is only going part way at the moment because it's just a small piece in there, but that's what this machine is for. So that's been our tour of the edge sharpening, and we want to thank Tom Saxby for showing us and explaining us all of the details of what goes into sharpening bits and blades for all of our woodworking tools.